23, we're going to factor difference of squares in the numerator. In the denominator, we just factor out an x. Okay, and so notice that none of the factors cancel. Nothing cancels here. So what does that mean? It means that there are no wholes. Okay, because no factor canceled in this problem. As for a vertical asymptote, it actually has two because there are two values that make the denominator 0. X equals 0 and x equals -8. Okay. Horizontal, this one has a horizontal asymptote. Now, we look at the leading terms in the numerator denominator, and it's better to look at it when it's not factored. So here and here. So they have the same degree on both the top and the bottom. So that means that we look at y equals a over b. A is 1, b is 1, because those are the leading coefficients. So y equals 1. Alright, so for number 25, they're asking for the domain. So we look at the denominator, and no x value makes the denominator 0, right? So the domain for this is all real numbers. Okay, for part B, they're asking you whether the function is continuous. That means that it has no gaps or holes. Well, because the denominator is all reals, it has no vertical asymptotes, right? And that creates a break in the graph. And there are no holes. That would also create a break in the graph. Since neither one of those exist, then we could say that this graph is continuous. That means there are no gaps or holes or anything. It's continuous. For part C, identify any horizontal and vertical asymptotes. Well, vertical asymptotes, we know there are none because the domain is all reals. And as for horizontal asymptotes, horizontal, we look at the degree in the numerator and the degree in the denominator, they're the same. So that means that in that case, if they're the same, then the horizontal asymptote is the A over the B. Well, B is actually 1, right? Because that's the coefficient of x squared. So then the horizontal asymptote would be y equals 5, because it's 5 over 1. And then plug the equation into Desmos.com, and you will see that it looks something like this, where this is 5. And it's not exactly like this, but I'm just giving you a rough sketch, and it goes something like this. It's a smoother curve, it doesn't have this little, but it's something like that. So you can see it's continuous, and the 5 gives you the y equals 5, that gives you the end behavior here on the left and the right side, and no vertical asymptotes. Alright, so for part A, they want the domain, so we look at the denominator, and from here I know that this is the difference of two cubes. If I write it like this, you could see, oops, let me just rewrite it. We have 27 minus x cubed like that. So this would be 3 minus x for the first factor. For the second one, remember we square the first number, 3 times 3 is 9, change the sign, we multiply this times this, so that gives us 3x, and then that one would always be positive, and then we square the x, the second term. So this is the factored form of the denominator, and like I reminded you guys in class today, this gives you no real zeros. Okay, only imaginary zeros. No real zeros. So the only real zero here is going to be from this factor. Okay, so for the domain, we're going to say that it's all x such that x cannot be 3. Okay, for part B, it says determine whether it's continuous. This is not continuous. How do I know that this function is not continuous? Because there's going to be a vertical asymptote at x equals 3. There's going to be a break in the graph. Okay, and for C, like I just said right now, the vertical asymptote is going to be at x equals 3. And as for the horizontal, I'm going to compare this degree with this degree. Notice how the numerator has the degree is smaller in the numerator than in the denominator. So then that means that we have a horizontal asymptote of y equals 0. Alright, so for 37 through 43, they want you to find the zeros. So remember, finding the zeros means finding the zeros of the numerator. Okay, so I have x plus 3, x minus 3. Once it's reduced, so, and the denominator does not factor because it's a sum of two. It's not the difference of squares, so I cannot write it. I can't factor it anymore. Okay, so that's, you just copy it down. And so what makes the numerator 0? Plus and minus 3. Okay, 39. Alright, so for 39, I'm going to go ahead and combine the two terms, the 1 plus 6 over x minus 3. So my common denominator is x minus 3, so it's going to be x minus 3 over x minus 3 plus 6 over x minus 3. So this is actually 1, right? I just gave it a common denominator of x minus 3, but this is equal to 1. Okay, so now I can combine the numerator and I get x plus 3, because minus 3 plus 6, over x minus 3. Okay, so now the zeros of this rational function, it only has 1, because I look at the numerator, and the only thing that makes the numerator 0 is negative 3. So just negative 3. So for 41, it's going to be x minus 5 times x plus 4 over x squared plus 7. Again, the denominator does not factor on this one. So the zeros are 5 and negative 4, because those are the ones that make the numerator 0. Alright, so for 43, the numerator is x plus 7, x minus 3. Denominator is x minus 3 times x minus 1. So the x minus 3, so the x minus 3 is cancels. So this one, if you were to graph it, that would create a hole in the graph. And so I'm left with x plus 7 over x minus 1. So the 0, it only has one 0, because the numerator is 0 when x is negative 7. So the 0 is negative 7.